Thank you for joining us. This session is to discuss the online and part-time graduate programs in applied biomedical engineering offered through the Whiting School of Engineering at Johns Hopkins University. We have a great panel for you this evening. My name is Sheryl Williams. I am the Assistant Director of Recruitment and Marketing for the Whiting School. To answer questions tonight, I have with us our Vice Chair, Dr. Brock Wester, Dr. Anil Maibate, Dr. Ariel Drummond. Completing our panel this evening is Luis Montes.
Thank you, Sheryl. I hope everybody can hear me now. And again, welcome to this info session for the Applied Biomedical Engineering, ABE in short. I am Anil Maibate, representing the faculty of ABE, and I would like to tell you a little bit about the program and later try to answer some of your questions. Now let me spend some time on the ABE program. It will be an understatement to say that modern biomedical engineering is a diverse field with specialties ranging from robotics, neuroprosthetics, medical instrumentation, immunoengineering, imaging, biomimetics, micro nanoelectronics, mathematical modeling, and of course signal processing. The field has been projected to show enormous job growth through this decade and beyond. Opportunities are expanding rapidly across all these specialties. At ABE, we aim to train you for these opportunities of the future through rigorous coursework as well as interactions and networking with our expert faculty. The ABE faculty comes from our BME department, which is ranked #1 in the country for many years now, from the renowned Applied Physics Laboratory, and also from a diverse range of topmost local biomedical and engineering industries. Next slide, please. Here, I want to highlight the most important points about our program. In ABE, you can apply for a master's degree in BME or a postmaster's certificate. Tonight, we will exclusively talk about the master's degree. In the master's program, you will be able to choose one of the 3 focus areas: medical imaging, medical instrumentation, or translational tissue engineering. You will need to complete a total of 10 courses in maximum 5 years. Typical students complete these in around 2 to 3 years. Most courses are offered online, with few still being offered on site at APL, but slowly moving online. In our core elective courses, focusing on each of these, you will find opportunities to acquire fundamental skill set, application-driven projects through homeworks, and hands-on laboratories. Later in the session, we will revisit the hands-on laboratory course with more details. Next slide, please. So who are our students? Well, the current average age of an ABE student is 27 years, with 24% living in Maryland, 72% living out of state, and 4% international. 96% have taken online classes. Importantly, 83% of ABE students are employed, and we have a list of few employers here on the slide. I should just mention here quickly that there is a latest news, exciting news from summer 2018 onwards. All online and part-time students also will now have access to something called Handshake at JHU. Handshake is the university's career management platform that features information on career-related events, webinars, job postings, and career resources available to all students from JHU. We encourage all of you, if you are on board, we encourage all of you to take full advantage of these valuable resources. Next slide, please. So let's talk about the nuts and bolts of the degree program. This is a 10-course degree that needs to be completed in maximum 5 years. Of the 10 total courses, 5 are required courses and include a laboratory course and a focus area course. The other 5 are selected by the students from a range of electives. Upon entering our program, you are assigned an advisor to help you design your personalized curriculum. That is to select an appropriate focus area and match electives to your academic interest and future goals. It is important to note here that you may also take electives from outside of the AB department and even outside of Whiting School of Engineering. For example, if you are particularly interested in biostatistics, there might be a course available in School of Public Health that we might be able to recommend. You can take up to 2 courses from outside of our department. In exceptional cases, we have also allowed a third one. As a part of the electives, you may also do up to 2 semesters long mentored research project aligned with your focus area. This can be done either within the JHU system or elsewhere. I'll talk briefly about this later in the session. Next slide, please. Let's dig a little deeper into the core requirements with the 5 courses. Here are the first 4 core courses required for the master's degree. Regardless of your focus area, all students must complete these 4 courses. 2 courses in physiology. These are your fundamental human body courses covering functions of organ systems with quantitative analysis. And 1 course in applied mathematics. That includes solving things like ordinary differential equations, partial differential equations, as well as other complex analysis related to biomedical engineering problems. The 4th required course is a hybrid online on-site lab course that operates over 2 separate 3-day weekends in the summer, each preceded by a period of 3 weeks of online preparatory learning. This is where you gain the hands-on practice I was talking about earlier. This is not your only opportunity to take a lab course, but it is the only required lab course for the degree. Dr. Drummond will be talking about it a bit later. Next slide, please. The 5th and the final required course depends on your focus area. As you can see on this slide, if you are in the imaging focus area, you take a fundamental course in medical imaging. That is principles of medical imaging. If you are in the instrumentation focus area, you will pick a course on instrumentation and devices, and so on. You get the point. Next slide, please. As I mentioned, we have 3 focus areas for the applied biomedical engineering. They are instrumentation, imaging, and translational tissue engineering. Dr. Haas, Dr. Wester, or me, one of us, will serve as your personal advisor to help you select the appropriate coursework for you. Let's step through some of the examples of how you may complete the ABE program with these 3 different focus areas. Of course, there are a large number of pathways to reach your goal of 10 courses. As you see, the example here is one for a student who is interested in instrumentation. The details of each course are accessible through individual course homepages, accessible from ep.jhu.edu. Next slide, please. The next example pathway is graduation for students interested in the imaging, as shown in the next slide. As with instrumentation, these courses include core courses, and the focus area course includes an imaging course and some electives which are related. Similar on to the next one. The final example pathway to the graduation for students interested in translational tissue engineering is shown in the next slide. Again, this example pathway includes the core courses, the focus area course, as well as some examples of electives relevant to that area. Next slide, please. Now I want to highlight some of the courses that we have recently added or will be adding in near future. As for the ones we recently added, I would like to mention a multi-instructor course in Frontiers in Neuroengineering that covers some active research topics in that field. Another one in brain-computer interface that we offer every summer. A spring course dedicated fully only to MR imaging in medicine. And another one on immunoengineering, that is the latest addition to our portfolio. Next slide, please. We are also planning some very exciting new online courses relevant to a modern biomedical engineer. A list is displayed here for you. All these courses should be up and running in the next 2 or 3 semesters. Again, I strongly recommend you to take a look at the course homepages from ep.jhu.edu. Next slide, please. Beyond the ABE courses, let me quickly display some of the courses available for you from the wider JHU system. For example, the BME department and the School of Medicine. Most of these are face-to-face courses, although some have now moved online. I should also mention that based on your incoming coursework, you may be able to place out some of the core requirements. However, this would not reduce your total degree requirement of 10 courses. You would work with your advisor to replace the opted out courses with more advanced or supplemental coursework in your focus area. And the last but important point to emphasize here, a minimum of 4 courses out of your total 10 courses are required to be at the 700 plus level to fulfill your degree requirements. Next slide, please. Okay, now I will hand it over to Dr. Drummond, who is here to discuss the hybrid lab course that I mentioned earlier. Formally, it is known as the Biomedical Engineering Practices and Innovation. She will also later talk about some application steps.
Okay, well, thank you, Dr. Mabate. So we're highlighting this course for you because it's something that really sets our program apart. As you know, we have moved many of our courses online to accommodate working professionals and family life for our students that are enrolled from all around the country. In addition to these online courses, this lab component offers our students a hands-on lab experience in a condensed course during the summer. The calendar structure for the course is very simple. There are 2 separate 3-day weekends over the summer with face-to-face portions that happen at the Homewood campus in our labs at JHU and downtown at the Johns Hopkins Hospital. Both of these 3-day lab weekends are preceded by 3 weeks each of an online preparatory phase to prep students for the labs. So students prepare online for 3 weeks and come over to the Homewood campus for a Friday to Sunday weekend for the labs. And then the students repeat this once more, totaling 8 weeks of an intense lab experience. So in this summer course, students conduct experiments across the 3 main focus areas in ABE: physiology, instrumentation, and tissue engineering. The labs are grouped so as to give you the best opportunity to learn. So for example, a physiology lab using frogs is used to investigate the Starling relationship in cardiac mechanics. And this will be paired with an instrumentation lab where students build and implement a basic EKG monitor. And with it, they can record their own EKG. In another lab, students interact with a robotic prosthetic hand brought in from APL and learn about brain-computer interfaces. You can go to the next slide. So additionally, as part of this unique course, our students are exposed to exemplary clinical faculty with a workshop at Hopkins Hospital and a tour of our excellent facilities for product translation, along with a panel discussion with biotech entrepreneurs. So as we mentioned earlier, you can apply for a master's degree in BME or a postmaster's certificate. So let's step through the application process briefly. The application has 3 components: the online application, submission of your academic transcripts, and professional resume. The review of your application will take typically 4 to 6 weeks. Although applications are accepted on a rolling basis, please keep in mind that the spring registration opens on October 25th of this year, and classes begin for the spring semester on January 28th of 2019. The eligibility for applying to our program is simple. The GRE is not required. However, you will need to hold a bachelor's degree or higher in a science or a related engineering field, which can include previous undergraduate level courses in fields like math, physics, chemistry, biology, and or any branch of engineering. Recently, we have had several students enroll in the program with medical degrees who have taken the required prerequisites prior to starting the ABE program. We admit students with a GPA of 3.0 or higher, and we also have listed the prerequisite coursework for admission into this program on this slide. So now I'd like to pass it back to Dr. Mabate to discuss a little bit more about our independent research projects.
Thank you, Ariel. Now I want to quickly highlight the opportunity for all AB students to complete a 1 or 2 semesters long research project under the supervision of a scientist mentor of their choice. Next slide, please. Each of these semesters long research period is equivalent to completing an 800 level course, each counting as one of the electives, with each being equivalent to 3 credits. For these project courses, 585.800 and 585.801, students are required to work with both a research mentor and an administrative AB mentor. Typically, the research mentor will be someone that the student herself finds and will be from the faculty members at JHU related research institutions or local to where the student comes from. The deliverable for each semester will be a final report, separate for the 2 semesters. For students doing 2 semesters long project, we also recommend that this be brought to an end with a potential publication of some sort. For more information, I encourage you to explore the course homepage linked here at the bottom and/or contact me directly for any questions and clarifications. Note that although we recommend that interested students should enroll in these project courses towards the end of their time in the program, we also recommend that they should start thinking about these much earlier, for example, after completing the core required courses. Next slide, please. As an exceptionally successful example of such a project, let me highlight this one by one of our past students, Matt Schaefer's project for redesigning the Ebola protection suit. The project was successful to the level of obtaining some seed funding from US government under the USAID program. It also attracted a lot of press coverage. You can find out about it by simply Googling JHU Ebola suit. In this project, along with other students, Matt was a part of a team, of a JHU team, that redesigned the personal protective gear for healthcare workers in the Ebola setting. Matt's specific focus was on designing a cooling system which would be integrated into the gear that the healthcare workers will wear. Cooling is a major issue for these workers, impacting how long they can care for the patients. Matt spent a whole semester working hand in hand with graduate students, fellows, local engineers, and APL staff for this project. The team now looks forward to seeing their efforts move on to the next phase of preclinical and clinical testing. So this was about a very successful recent example of a student's research project within the AB program. Other students have recently participated in similar projects and have had opportunities to file provisional patents, etc., utilizing the openly available resources and guidelines from the tech transfer personnel at JHU. You will also have a chance to explore these type of opportunities. Now, as you know, we have a student on this panel waiting to interact with you and briefly providing you with some insight from a student's perspective. Luis Montes has been with us for at least for a couple of years and will be graduating soon. I would love to now hand it over to him so that he can share his own experiences with you.
Thanks, Professor. So hi, everyone. Professor said, my name is Luis Montes. And I'm going to share a little bit of what my experience has been inside the program. So I completed my undergraduate studies at the University of Hartford, originally with plans of going back home to Puerto Rico and do a PhD in bioengineering. However, when I got accepted into a rotational program in the workforce at Engine Manufacturing, it was too good of an opportunity to pass off. So I applied to this program with hopes of still being able to continue my graduate studies. So once I went through the admission process and was accepted, I immediately started working and doing my master's at the same time. And I've been able to manage by taking a max of 2 courses per semester. I've usually taken 1. This is the first semester in which I'm taking 2, and the next one I'll do the same before I graduate. You should expect to be putting in between 10 to 20 hours per class per week. In my experience, the courses are designed with enough coursework to maintain a balance between work and school, but enough content to also feel like an in-person lecture course. Additionally, office hours are always available and provide enough time for students to clarify any questions that you might have related to specific coursework. So personally, what I've enjoyed the most is how I've been able to pretty much apply everything that I've learned directly into my work environment. This was a case in which I worked as a compliance officer where I work, and I was able to apply the information that I gathered for my regulation of medical devices course. And also that is the case for my independent study, which I am doing in collaboration between the program and my workplace, Amgen. Lastly, the on-campus labs that are part of the core courses, which you'll be taking, provide a great look into all 3 major areas of the program in a very efficient time period. So, I mean, I guess the biggest takeaway here is that, in conclusion, I would definitely recommend the program to anyone interested in this field, especially those that, like me, are advancing their graduate studies while working.
All right, thank you, Luis. Some of the most common questions that we get from prospective students is, what is the tuition and what resources are available to help me pay? So here it is. Our tuition is currently $4,250 a course. Our courses are 3 credits each, so this is the total tuition cost for each 3-credit course. Because our tuition fluctuates every year due to inflation, we encourage students to budget $45,000 total for their degree. This cost may exclude books and materials. The cost of books and materials really depends on the coursework that you register for. However, in addition to tuition, our students do not pay any regular fees. So, for example, we do not charge our students a technology fee on a regular basis. Our online and part-time students do not pay any fees that are typically associated with a full-time residential program. So, for example, there's no administrative fee, there's no student union fee. We do not charge a fee to submit your application for admissions, so there is no application fee. The only fee that we charge our students, or you can expect to pay as a student, is a fee at the end of your course of study with us, known as a graduate's fee. You have a variety of financing options available to you depending on your personal circumstance. I really encourage you to investigate and to take advantage of any education benefits that your employer may offer you. We unfortunately do not have any scholarships available for our online and part-time graduate students, but there are other associations and organizations that do. For example, the National Consortium for Graduate Degrees for Minorities in Engineering, otherwise known as the National GEM Consortium, offers fellowship programs. Rules, requirements, and application instructions can be found on GEM's website. Simply search GEM to locate their website. The application for these fellowship programs is open from July 1st to November the 13th. If you are a U.S. citizen or a qualifying U.S. resident, you may be eligible to use financial aid. The financial aid that's available for graduate students is largely unsubsidized loans. So similar to that, you can, of course, finance your education through a personal loan. And if you are active duty and retired military and you have veterans benefits, you can, of course, utilize these to finance your education. Speaking of which, we do have a number of active duty and retired military enrolled in our online and part-time programs. If you are planning on using veterans benefits to finance your education, here are things to keep in mind. So the URL that you see here on the screen, ep.jhu.edu/veterans, has some great information on the forms that you need to submit in order to utilize veterans benefits at Johns Hopkins. Our certifying official, her name is Nancy Carr. She is wonderful. She's very responsive, and again, her contact information can be found at this URL. For Chapter 33 post 9/11 benefit recipients, please know that the Department of Veterans Affairs sets an annual cap on tuition for private schools. That cap is currently $23,671.94, and that is for an entire academic school year. So it includes the fall, spring, and summer semesters, and then it renews every fall. 5 courses over that period of time, 5 courses will come in underneath the tuition cap. The cost for 5 courses is $21,250. 6 courses, however, will exceed the tuition cap. Johns Hopkins is a yellow ribbon school. How yellow ribbon works at Johns Hopkins is that it is applied in the summer semester or once the tuition cap is exceeded. And if it is exceeded, qualifying students can receive up to $1,000 per year. It's awarded on a first come, first served basis. So as of this fall, the VA has made some changes regarding how they are calculating housing allowance for Chapter 33 recipients. BAH, your basic housing allowance, is now calculated using the zip code for your on-site classes, i.e. the physical location of the classroom utilized. We wanted to take a moment and just let you know that Hopkins actually offers various networking opportunities for our veteran students. For current students, there is a online networking group that's available via LinkedIn. Simply search Johns Hopkins Veterans to locate that group. The full name is the Johns Hopkins University Veterans Connection Group. For our alumni, we offer a networking group through our Alumni Affinity office, and you can learn more information by visiting alumni.jhu.edu. For students who are educated outside of the U.S., you do have some additional admissions requirements, some additional documents that you will need to submit. Those being, these students will need to submit an international credit evaluation of any credit earned at non-U.S. institutions. We prefer that students go through WES for this document. WES is a third-party credit evaluation agency. The product that you want to request from WES is known as the ICAP. These students will also have to provide proof of English proficiency via, for example, qualifying scores on a TOEFL exam. Now, I just wanted to take a moment here and say everybody is welcome to enroll in our online programs, regardless of your residency, whether you're living in the U.S. or outside of the U.S. We encourage you to study with us online. We have a large body of coursework available in this program and also across all of our online and part-time programs. Across all of our engineering online and part-time programs, we actually have 310 online courses. So there's a great wealth of content available to you online. Students who are studying on an F1 student visa, unfortunately, are not eligible to enroll in our online and part-time programs. The reason for that is that we're moving more and more of our coursework online at the request of our students. And the registrar's office made an executive decision, like en masse, that because we are moving more and more of this coursework online, there's going to be a point where we just are not able to issue the Form I-20, which, if you don't know, the Form I-20 is what you need to maintain that F1 student visa. It's a form that says that you are indeed studying on site at the university. All right, next steps. Quick review. If you're interested in studying with us, your first step is to submit your online application. You can do that by visiting this URL, ep.jhu.edu/apply. And then next, to submit your academic transcripts and your professional resume. By the way, the instructions on where to send those documents can actually be found at this URL. It's located in the text above the application form. Important dates: spring registration. It opens on October the 25th, so later this month, and the spring term actually begins on January 28th of 2019.